Hello, this is Kori Pekarek, and today I'm going to explain how many nice polyhedrons there are. A polyhedron is a 3D polygon where all of the sides of the 3D object are made out of the same regular polygon. So there's only one type of side. So the way we look at the tool we use to look at the polyhedrons or any like 3D shape is a net, which is like if you picture like folding out all of the sides of the shape into like one like flat shape. So we're gonna use a net, and then there are some rules we're gonna use to figure out if the polyhedron is possible or not. The first rule is that there needs to be more than 3 or more sides at each vertex. And the reason for this is like if you picture if part of a net was like 2 squares like this, where there's only 2 squares touching, like at this vertex, if you imagine these two sides like folding together, it would just be like a flat square. It wouldn't actually be a 3D object. So there needs to be at least 3 shapes at a vertex in order to make the object 3D. And then the sum of the angles at each vertex has to be less than 360 degrees. And the reason for that is now if you picture the shapes at this, or the shapes at this vertex filling up all 360 degrees, since there's no open space, there's no way that these shapes could like fold up. That like wouldn't be possible. So these are the 2 rules we're going to use when deciding if the polyhedron is possible or not. So we're going to start with triangles, and so we're going to list the number of sides on this side of the chart, and then on this side we're going to say the sum of the angles to figure out if it follows both rules, if it's greater than 3 sides and if the sum of the angles is less than 360. And the equation we're going to use to figure out what the angle measure is of the regular polygons is 180 times n. N is the number of sides on the polygon, minus 360 over n. So that's how we're going to figure out the angle of one side of the polygons in order to figure out this number over here. So we'll start with triangles having 3 at a vertex because automatically anything under 3 won't work. So if we're going to have 3 at a vertex, and when we plug 3 into this equation, you get 60. So the sum of the angles will be 3 times 60, which equals 180. So this is an instance that will work, so we'll just put a little check by that. And now we'll do 4 triangles at a vertex would be 4 then times 60. So that'll be 240 degrees, and that's still less than 360 degrees, so this one will work as well. And then 5 sides at a vertex will be 5 times 60, which is 300 degrees. So this is still going to work because it's still under 360. And then when we try 6 sides at a vertex, that will be 6 times 60 degrees, which will end up equaling exactly 360. So once we get to 6 sides at a vertex, that's not going to be possible because it doesn't follow the rule of the sum of the angles being less than 360. So now we've figured out that these are the 3 possibilities for the number of triangles that can be at a vertex in order to create a nice polyhedron. So now we're going to move on to squares, and we're going to use the same chart. So we'll start with 3 again for squares. And then we're not going to use this equation for squares because we already know that each angle in a square is 90 degrees. So the sum of the angles for the 3 sides square will be just 3 times 90, which will equal 270 degrees. So that will work because we have at least 3 sides and less than 360 degrees. And then if we try 4 squares, that will be 4 times 90, which equals 360 exactly. So this will not be a nice polyhedron because it doesn't follow the 360 degrees rule. Now we will try pentagons. We'll start with 3 sides again. And then when we when we plug in the 5 for the number of sides on a pentagon into this equation, we get 108 degrees. So this will be, the sum of the angles will be 3 times 108, which equals 324. So this is an instance that works. And then since we're, or no, I guess we'll move up to 4 sides. And this will be 4 times 108, which will be 432. And that is, that's obviously way over 360. So this is not an instance that works. So we have one instance for pentagons that work. And now we'll move on to hexagons. When we plug 6 into this equation, we get 120 degrees. So 3 times 120 equals 360. So there won't be any instances for pentagons that work. Oh, hexagons. My bad. We did have one instance for pentagons that worked, but for hexagons, right when we get to 3, it's already at 360. So hexagons won't work. And then as we keep, there won't be any shape with more sides than 6 that will work, because as we keep getting more and more sides, the angles will keep getting bigger. So the 3 sides at a vertex will never drop below 360 again. So to review, we have 5, or we discovered that there are 5 nice polyhedrons, and those are a triangle with 3 sides at a vertex, equilateral triangles with 4 sides at a vertex, and equilaterals with 5 sides at a vertex, and then squares with 3 sides at a vertex, and pentagons with 3 sides at a vertex. Thank you for listening.